record. Okay, so here's what we're going to do today. Today, what we're going to be talking about is solutions and systems, okay? Now, that is a title that I made up completely and totally off the top of my head because I was trying to think about how to summarize what we're doing today. And today's date is the 25th of January. It's coming so close to the end of this month already, which is really weird to me. Okay, so here's what we're going to be talking about. I want to talk about solutions for just a second, and this is the reason why. Because for the whole last week, and really even the week before that, what we were doing here is we were talking about linear equations, right? And we would start off, and you would have something like y equals, this is my example, sorry, y equals 2x plus 1, and I would say, okay, make a graph for that. And you know, you guys have done a really good job with that. So if I said, do this and graph it, could somebody tell me, how do we do that? Like, what do we do with this to graph it? Just take through somebody type in the chat and tell me, like, what do I do first? What do I do second? All that stuff. What's my first thing? Anybody remember this from last week? Find 1 on the y-axis. That's absolutely right. So our first thing, I'm going to try to do this in 2 different colors if I can. So we take this guy here. This is our y-intercept, and we would do that on the y-axis. That is the 0, 1, and I'll graph this in just a second. And then after I know that I start there, what do I do after that? What's my next thing? Oh, somebody else got to type it for me. After I've found the 1 on the y-axis and I graph it, what do I do next? 2 over 1. And that is our slope. That's absolutely right. We take the number in front of the x. We say that our slope is that number 2 over 1. And we got to remember, we do that. The top number is our change in y. That bottom number is our change in x. So we go up 2 and to the right 1 for my graph. Now, all of this is important, okay? All of this is what I need to do to be able to find these graphs and do what I need to do. And you guys have done a very good job of looking at this. So when I do it, I'm going to try to do a really quick graph of this right next to it here. We'll just do this directly on here. So we started off, I folded this so we have space for both. We started off at that 0, 1, right, like we said. And then if we're going to be going up 2 over 1 for our slope, we're going to go here up 2 over 1. And I'm just going to keep doing that same thing until I run out of graph. And then I've got my line that goes up through here and goes down this way. Okay, great. All of that's there. Now, here's where it's important for us to think about this. What the hell does that mean? That's the part that, like, I realize that a lot of what we've been doing in math recently has been, this is what you do. Do this. No, do this. And that's fine. But it doesn't give you a chance to understand what the heck is happening and why are we doing this in the first place. So this is what I need you to understand about the graph. What the graph is, this graph is the set of every single possible solution you could ever have for this equation. So these points that I made here are great because those are the points that I can connect. But literally any point on this line is something that I plug into the x and the y, it'll be a solution. Even if I pick something in the middle here that's like a halfway point, or this little point right here next to that, or way up here, anything on this line is a solution to this equation. Now, I'm going to do something really quickly for you guys to kind of see what I'm talking about, okay? So like right here, this point here is 4, 9. This point here is 3, 7. This point here is 2, 5. Man, it's hard because this is like, that looks like an 8. It's not, it's a 5. I'm sorry about that. 2, 5. And this one right here is 1, 3. And so what I mean is these are my whole number points. Any one of these is a solution to that equation right there. And what I'm going to do right now is take this off and copy those points down. So we had 4, 9 was one of them, 3, 7, 2, 5, 1, 3. All of these are points that we just found because we graphed them on there. Now, most of the time when I'm asking you to graph a point on the line, I'm not asking you to plug this in and check and see if it works, but I want to show you that it does actually work. Oh, are you kidding me? Chandler, did you just change your picture so that it was WandaVision? Stop it. Stop distracting me. Okay, so here's what I want to do. I want to show you how this is going to work. So if I take this equation here where y is equal to 2x plus 1, what we have to remember is that these are all our x's and these are all our y's. So if I'm looking at this, this is like a table of values, right? And what this would mean is that if I take this equation right here and I plug these in, it's going to give me an answer that should make it true. Now, if it doesn't make it true, then I've done something wrong. And I'm going to tell you right now, we're not going to do all 4 of these. I'm just going to plug like 2 of them in to show you that it works. But understand, if they're on that line, they're a solution to this equation. Okay, so y equals 2x plus 1. Let's use 4 and 9. My y is that 9. Okay, so let me write this over on the top so I'm not screwing this up. Okay, so I'm just going to plug them each in. In this case, y is 9. 9 equals, and then here it's 2 times that 4 plus 1. So if you see what I did, I just took the x and plugged it in, took the y and plugged it in, and we're going to see if this works. All right, 2 times 4 is 8. 8 plus 1 is 9. Check, it worked. Hey, let's do it with 2 and 5 as well, just to be sure that I'm not full of crap, because this is 2 times something plus 1. So 5 is my y, 2 is my x. Let's just check the math. 2 times 2 is 4, plus 1 equals 5. Check. So what I'm showing you is that when we graph our line, like we did here, every point that we find on here is something that when I plug it in here, it makes this equation true. It's the reason why I can't use a point over here. This guy over here, if I did negative 4, 7, that is not on my line, because if I plug in negative 4 here, I'm not going to get out of 7. Or if I plug in something down here like 5, negative 2, it's not going to work because that doesn't make this true. But anything that falls on here, even if they're fractions, those are the points that are actually going to work. Now, we never look at the fractions. We always look at the whole numbers. But that's kind of what we're going to be looking at. And so this is the reason why that's important. It's not important because I'm going to use this to find tons and tons of answers to our equation. But it is important when we do what we're going to be talking about today, and that's looking at a system of equations. Now, this is where it gets confusing, isn't the right word. It gets a little bit more complicated, okay? What we're going to be dealing with is going to be a system of equations. So let me write this down right now. And this is something where I don't generally like write all the words out, but it is a pretty good thing to have written down someplace. So if I'm talking about a system of equations, what I'm talking about for something like this is 2 or more equations whose solution makes them all true at the same time. God, a lot of words. Hard to write all these words. And if you guys were in person, I'd be making you do this all the time. Be like, what? 2 or more equations? What? What are you talking about? So, system of equations, I'm basically talking about, hey, look, I'm going to give you more than one equation. I want you to find the x and y value that when we put them together and make both of them true at the same time. Now, I could give you a system of equations with more than 2 equations. I could make them very complicated, and that would be very important for us to think about. But that would be dumb to do right now. So I'm going to tell you right now, always going to be 2 equations. And for right now, to solve our system of equations, they're always going to be things that look like lines. They're always going to be in that format of the slope-intercept form. Y is equal to the slope times x plus the y-intercept. They will all look like that because it gives us a place to start with as we're going to be looking at it and working with it. So let me give you a really quick example of something that I think is going to make sense. Now, when I do this, I want to sort of show you how this is going to work. So I'm going to go, here is our example for our system of equations. And I'm going to do 2 different colors of equations here for you to look at it. So one of them is going to be y is equal to 2x plus 1. And then the other one that I'm going to do, I do in this color, y is equal to negative 3x. And give me a second to see how I'm going to plug this in here. Sorry, Normally, I don't do this, but this will be fine. Negative 3x. Then it's going to be. Am I going to be able to do this? Sorry, I haven't created this off the top of my head, so I'm trying to make one that has a good solution here. So give me just a second to make sure that I don't have my head up my butt here, and that's the problem. So that's going to be there, and that's going to be here. That'll be much easier. So this. There we go. Negative 3x minus 4 should work. No, minus 2. Minus 2. Negative 3x minus 2. Sorry. Guys, I know how much fun it is for you to look at this, and that'll be great. Okay, everybody ready? Right now, how many of you are confused as hell because I just sort of made up a problem in front of you, and you're like, what did he just do? Anybody confused? All right, good. I'm glad that you're confused. I'm going to explain to you why this is a little bit weird in just a second. So here's the deal. 2x plus 1, I got a whole lot of possible answers. Negative 3x minus 2, I got a whole number of possible answers. If I want to find the one solution that makes them both true at the same time, then my easiest way of finding a solution graph them both and see where they cross. Because when they cross, they have the same point at the same time. This point where they cross is a point that they both share. And if they both share that point, then that means it's going to be a solution to that system of equations. Now, this is a bit of a pain if you don't do it correctly. So what I'm going to try very hard to do right now is I'm going to try to get this in a place that we can look at them at the same time, okay? So here's the way we're going to start. I got this right here. If I'm going to talk about this green one right here, let's do that first. Where do I start this graph? Y is equal to 2x plus 1. Where does that start? Oh, somebody's got to type it in there. Where does 2x plus 1 start? 1. Absolutely right. It starts at 1 on the y-axis. So I'm going to start this right here. Okay. What is the slope of this line? 2 over 1. Okay. So 2 over 1 is my slope, which means I'm going to be going up 2 and to the right 1. So I'm going to take this one, and I'm going to go all the way up 2 to the right 1. I'm going to go until I run out of graph. Now, I do want to tell you something. When you are graphing to find a solution to the system of equations, you want to do this, but you want to go all the way in both directions because there's lots of places where these two lines could cross. So I went up here because I want all of my points. Instead of going up 2 and over 1, I'm going to do that same sort of step pattern, but go down this way because the line continues forever. And if you have these marked off, that gives you lots of places that if it crosses there, we can see where it looks. So this right here is my full line for y is equal to 2x plus 1. That is every possible solution that is on the graph. Everybody good so far? Okay, I got one yeah. Yeah works for me. Now, what about this one? The y equals negative 3x minus 2. Where do I start with that? Negative 2 on the y-axis. Now, I've got to make sure that I have my head in the game about this one for just a minute, because what should happen, and I don't know if I did right or not. No, I was right. God darn it. Okay. I had written the correct equation, and then it didn't work because I was a fool. I'm sorry. I'm trying to do this up in my head, and it's really hard to do. This is negative 3x minus 4 is what it should be. So I don't start at negative 2 on the y-axis. I'm looking at it like, well, that's not going to work. But this is going to work. Negative 3x minus 4 is what I wanted. I tried to write it down, and I convinced myself I was wrong, and I looked at it, and I was like, bleh. This is the right equation. So if I want y equals negative 3x minus 4, I actually go to negative 4 on the y-axis. And then I look at my slope. What is my slope here? Negative 3 over 1, which means I go down 3 and I go to the right 1. All right, so here, down 3 to the right 1, down 3 to the right 1. Now you notice if I keep going in this direction, will I cross this line at all? No. So what I have to do is not just continue this way, but I've got to continue in the opposite direction as well. So instead of going the steps like this, I'm going to keep doing the steps this way and keep doing them exactly the way that I've done them. So I've got enough space here to see where will the two of these cross. Now, do you guys see that the two of these equations cross? Yeah. So what you need to be able to do then is to say, if I know that these two equations cross, I got to find that intersection point, and that guy is right here. Well, hey, look at that. That's the place where they cross. And then I got to say what that point is. Well, right there, my x value is -1. My y value is also -1. So if I've got -1, -1, that is the solution to both of these. So this is the solution. Now, the reason why it sometimes takes a minute for me to get my head around what's going to happen here is I had not started with a solution. I tried to start with an equation and work my way through it, and that's harder. Sometimes if I'm creating an equation on the fly, I've got to put it in my head and then figure out how this is going to go. So as I'm looking at this, that is the process that we use to solve a system of equations. We take the equation, we graph the equation, we find where they cross, and then that's our answer, because that is the one point that they both have in common. Now, I'm going to take a second and I'm going to create another problem like this for us to look at. And I want you guys to sort of talk me through this on the chat as well. Again, I'm going to start a little bit less kind of off, because what I had not done very well with that is to sort of work through the way this was going to go. And I didn't want that to be a problem. So I'm going to create an equation as I am talking to you. So you can go, oh, well, I see what's happening here. This might take just a second. All right, and then I got this one. And that is going to be, I want to get to there. There we go. All right, so I believe these two equations should work just fine, but we're going to see how this is going to go. My two equations that we're going to actually work with now, and I'm going to use the same two colors because I think they're pretty good, are going to be y is equal to 3x minus 7. So that's going to be one of them. And the other one is going to be y is equal to -1x plus 5. Okay, now I have looked at this one and I know that it's going to work. But before we do it, let's make sure we know what we're doing with each. So with the green one, somebody tell me, where do I start this graph? I ordered at 7. Now, is it a positive or a -7, Bryson? -7. Absolutely right. So that's going to be on the y-axis. So my y-intercept is 0, -7. Okay. What is the slope for this one? This is anybody. What's the slope for this top equation? Jemiah, you're right. 3 over 1, because I've got that number 3, which means I'm going to have 3 over 1. So I'm going to be going up 3 for the right one. So that's how I'm graphing that one. Okay. One of the equations we will have figured out. We've got it just set up just like that. Okay. Same general idea. Let's do the bottom one. Where do I start with y equals -1x plus 5? 5 is correct. 0, 5 is where I start this one on the y-axis. And what is the slope for this one? 1 over 1 is right, but let's not forget that negative. Going to be -1 over 1. And the reason why that's important is if it's negative, instead of going up, that -1 tells me I'm going to be going down 1 and to the right 1. So this graph, the line is going to be going uphill. This graph, the line is going to be going downhill. So I'm going to guarantee you they're going to cross somewhere. It's just a matter of where and how do I get to it. So with that being said, let's take a look and see if we can graph both of those on the same graph. All right, here we go. Top one, just like you guys said, I'm going to start at that 0, -7. So that's all the way down here. My slope tells me 3/1. So I'm going to go up 3 to the right 1. And I'm just going to keep doing that. Up 3 to the right 1. And when I do this all the way across here. Now, when you do this on delta math, man, it's gonna do the entire thing for you. So you should be fine. And you'll see the entire line really quickly. But that is my graph of y equals 3x minus 7. I will connect all of these points. It gets me all the way through it. That is every possible answer to that one. Now I'm going to do y equals -1x plus 5. I'm going to start up at the 5. The -1x means I'm going to be going down 1 to the right 1, and I'm going to keep doing that. Now, with this one, once you see where they cross, I kind of have enough points here, right? I know they cross here. I don't need to know these very specific points, but this part right here, I do need to know because I do now have a solution. I have a place where those two lines cross right here. So could somebody tell me what is the point right there where those two lines cross? I got a 2 and a 3. I got a question. Which one do I put first? Do I put the 3 first or do I put the 2 first? If I'm doing the graph of this one, I'm going to want to do the 3 first because I want to do the x first. And then 2 up is where I've got this one. So 3, 2 is the final solution for this one for us to kind of go through and figure this out. Now, I can look at that too. When I made this problem up, I put a 3 here and said 3 times 3 is 9, minus 7 is 2. I said -1 times 3 is -3 plus 5 is 2. So that gave me 3, 2 for both of them to get the answer. Now, guys, this is kind of a lot of crap to deal with all at the same time. So here's what I would like to do really quickly. I've gone through a pretty good set of examples. But I also know that sometimes it looks a little bit different when you do this on there. And we do have 3 minutes. We need cleanup time in school. Okay, so here's what we're going to do. Guys, with the 3 minutes that we have left, what I'm going to do is stop recording, and I am going to take us for the end of this